Welcome to the dawn of MAI, superintelligence meets economic reality. This is Microsoft's 2026 Agent First model family, and the story of how it ends the enterprise AI cost crisis. This presentation from Precision Foundry examines why Microsoft built the MAI family from scratch, what the architecture actually looks like under the hood, and why it fundamentally changes the economics of deploying intelligence at enterprise scale. Let's begin. The enterprise AI paradox. Capability is soaring. Budgets are breaking. Frontier model dependency has created an unsustainable cost trajectory. The chart tells the story plainly. AI capability has grown exponentially, but enterprise token costs have grown even faster, diverging into a crisis. Microsoft AI lead Mustafa Suleyman stated it directly. Anthropic is extremely expensive and many are urgently looking for alternatives. We pay a lot of money to Anthropic, so our goal is to reduce and ultimately eliminate that cost. The enterprise reality is even starker. Uber burned through its entire 2026 AI coding budget in 4 months and was forced to introduce a strict $1,500 monthly cap per employee. This is not a niche problem. Every organization scaling AI workloads is facing the same wall. The models capable enough to do real work are too expensive to run at scale, and the cheap models are too weak to be useful. The MAI family is Microsoft's answer to that paradox. Before examining what MAI is, it is essential to understand a critical risk it was designed to avoid: distillation. Many midweight AI models are built by imitating the outputs of larger, more powerful models, a process called distillation. It is fast, cheap, and legally dangerous. Midweight models built through distillation of third-party outputs create fundamental legal vulnerabilities. Murky data sourcing risks copyright infringement and severely limits the steerability of the resulting model. Because you cannot fully control something you do not own at the data level. The MAI standard is the opposite of this. Every MAI model was trained entirely from scratch on clean, commercially licensed data. Zero reliance on third-party model outputs. The result is enterprise-grade data lineage, ready for regulated production environments where IP provenance is not optional. This is what Precision Foundry calls zero distillation, and for legal and compliance teams evaluating AI models, it is arguably as important as any benchmark score. The 2026 MAI family, set in self-developed models. 1. Agent-first strategy. Microsoft has organized the MAI family into 3 pillars. The reasoning pillar is anchored by MAI Thinking 1, the flagship logic model for complex, multi-step problem solving. This is the model that competes directly with frontier reasoning systems. The code pillar is MAI Code 1 Flash, a 5 billion parameter speed king trained inside the GitHub Copilot production harness and integrated directly into GitHub Copilot for developer workflows. The specialized pillar contains 4 models targeting modalities beyond text: MAI Image 2.5 and its Flash variant for design-ready text-to-image generation, MAI Voice 2 and its Flash variant for 15-language high-fidelity speech generation, and MAI Transcribe 1.5 for state-of-the-art multilingual speech-to-text across 43 languages. 7 models, each purpose-built, each connected to Microsoft's existing enterprise surface area. The architecture of efficiency. Heavyweight capability through a sparse mixture of experts. This is the technical breakthrough that makes MAI's economics possible. The mechanism. MAI Thinking 1 has 1 trillion total parameters, but only 35 billion are active at any given moment. Through a sparse mixture of experts architecture, the model contains 512 expert subnetworks. For any given input token, a router selects only 8 of those 512 experts to activate. Those 8 experts process the token through a dispatch operation, combine their outputs, and produce the result. The impact is profound. Only 8 out of 512 experts activate for any given token in a compressed latent space. The result is near-frontier intelligence operating at midweight inference pricing. You get the reasoning quality of a trillion-parameter model at the compute cost of a 35 billion parameter dense model. This is not a compromise. It is an architectural innovation that breaks the traditional relationship between capability and cost. Flagship reasoning, MAI Thinking 1. The ultimate hill-climbing machine for STEM and logic. 3 benchmark results define its capability profile. AIM 2025. The American Invitational Mathematics Examination, one of the hardest math competitions in the world. 97.0%. This is extraordinary performance on a benchmark that tests genuine multi-step mathematical reasoning, not pattern matching. LCB version 6 hard. Competitive programming problems at the hardest difficulty tier, 87.7%. SWE bench verified. Real-world software engineering tasks drawn from actual GitHub issues, 73.5%. The model supports a 256,000 token context window, approximately 600 pages of text, with native function calling and structured tool use built in. Importantly, all three benchmark curves show continuous improvement as compute steps increase, demonstrating that MAI Thinking 1 is a genuine hill-climbing reasoner. More compute produces better answers. This is the behavior required for long-horizon agentic tasks. The Speed King MAI Code 1 Flash adaptive thinking drives up to 60% token reduction. Two innovations define this model. First, it was trained inside the GitHub Copilot production harness, not on static code from the internet, but on real developer interaction data from one of the world's largest coding assistant deployments. The model learned from how developers actually work, not just from what code looks like. Second, adaptive solution length control. The model calibrates its response depth to the complexity of the problem. Simple refactors generate approximately 80 tokens. Multi-file architecture changes generate approximately 500 tokens. The result, competitor models generate bloated responses of similar length regardless of task complexity. MAI Code 1 Flash produces appropriately sized responses, completing the same tasks with 60% fewer tokens. At enterprise scale, where a coding assistant is making thousands of API calls per day per developer, a 60% reduction in token consumption is a fundamental budget transformation. The specialized models, expanding intelligence to vision, voice, and audio. Three specialized models round out the MAI family. MAI Transcribed 1.5 is a state-of-the-art speech-to-text system with accuracy across 43 languages. Its keyword biasing feature reduces word error rate by 30% on enterprise acronyms, a critical advantage in corporate environments where proprietary terminology is the norm. Most impressive, it transcribes 1 hour of audio in under 15 seconds, 5 times faster than competitive alternatives. MAI Voice 2 delivers high-fidelity speech generation with voice adaptation from incredibly short audio samples. For enterprises building voice-enabled agents and customer interaction systems, this capability enables branded, consistent voice experiences without extensive voice recording infrastructure. MAI Image 2.5 has surpassed Google Nano Banana 2 on the ARIA benchmark for image generation quality. It is specifically optimized for design-ready text-to-image output and layout editing, making it directly applicable to marketing, content, and product design workflows. The cost and capability matrix, breaking the traditional trade-off between power and price. The scatter plot maps the AI landscape. Expensive frontier models cluster in the top left, high capability, high cost. Legacy models cluster in the bottom right, low cost, low capability. There has historically been no way to occupy the top right quadrant, high capability at low cost. The MAI family occupies exactly that quadrant. Microsoft's midweight strategy, by optimizing the 35 billion active parameter mixture of experts architecture, MAI delivers frontier-level reasoning logic at a fraction of the token cost. The practical implication is significant. High-volume daily workflows no longer require budget-breaking dense models. Tasks that previously demanded a frontier model call, and the associated cost, can now be handled by MAI at a fraction of the price with comparable quality. This is not a marginal improvement in the cost-performance curve. It is a structural repositioning of where enterprise AI economics sit. The coding and reasoning battle, matching Opus, crushing Haiku. 3 head-to-head comparisons against Anthropic's Claude family make the competitive position concrete. On SWE Bench Pro, for real-world multi-file coding, MAI Code 1 Flash scores 51.2%. Claude Haiku 4.5 scores 35.2%. That is a 16-point lead, a massive margin on a benchmark that tests actual production coding tasks. On SWE Bench Pro for heavy reasoning, MAI Thinking 1 scores 52.8%. Claude Opus 4.6 scores 53.4%. That is a statistical tie. MAI Thinking 1 matches Anthropic's flagship model, which costs significantly more per token. On overall human preference in blind rater evaluation, MAI Thinking 1 is preferred over Claude Sonnet 4.6, which trails by a significant margin. The strategic implication is explicit in the headline. MAI matches Opus on heavy reasoning and crushes Haiku on coding, while occupying a fundamentally more cost-efficient pricing tier. The frontier battle, MAI versus GPT-5.x, winning the price-to-performance ratio. The radar chart compares MAI Thinking 1 and GPT-5.4 across 5 dimensions: math on AIM, enterprise coding, high-end science on GPQA, cost efficiency, and token optimization. The reality check. OpenAI maintains a slight absolute edge on high-end GPQA science benchmarks. That is the honest assessment. But the MAI advantage is compelling on the dimensions that matter for enterprise deployment. Math parity, 97% on AIM 2025. Functionally equivalent to GPT-5.x on mathematical reasoning. The TCO victory. Through hardware and software co-design with the MAI 200 chip, MAI achieves up to 10 times better cost efficiency than the GPT-5 generation for specific enterprise workflows. The framing is precise. MAI does not claim to be the objectively best model in every dimension. It claims to be the best model at the intersection of capability and cost that enterprises actually need at scale. That is a different and arguably more valuable competitive position. Frontier tuning. Make the model yours. Learning on the job. In your environment. The old way of model customization relied purely on generic public corpora, a model trained on internet data and then fine-tuned on a few examples of your documents. This approach produces marginal improvement in domain-specific performance. The frontier tuning approach is architecturally different. It customizes the MAI model using your organization's unique operational data, specifically the real-world trajectory of your agents, the actual steps taken, decisions made, and outcomes observed during production runs. This is not fine-tuning on documents. It is fine-tuning on behavior, teaching the model to replicate the decision-making patterns of your best-performing automated workflows. The case study makes the business case concrete. McKinsey achieved the highest win rate among all tested models after frontier tuning a MAI model, while simultaneously reducing costs by 10 times. When a model learns from the actual operational data of your enterprise, it stops being a generic intelligence and becomes a specialized cognitive asset. The MXC Security Sandbox, drawing the red line for autonomous agents. As AI agents gain the ability to take real actions, writing files, accessing networks, modifying systems, the attack surface expands dramatically. Unchecked autonomy exposes enterprise networks to a new category of risk. Microsoft's solution is the Microsoft Execution Container, or MXC, a policy-driven execution layer built directly into Windows. MXC operates on three principles. First, it decouples agent execution from the desktop, clipboard, and input systems, so an agent cannot silently read your clipboard, observe your screen, or inject keystrokes outside its defined sigil. Second, all tool execution happens inside sandbox execution environments, which are isolated containers with explicitly defined permissions for files, clipboard access, and network connectivity. Third, the agent control specification ensures full auditability via Microsoft Entra. Every agent action is logged and attributable to a specific identity. For enterprise security and compliance teams, MXC transforms the AI agent from an unauditable black box into a governed, traceable process with the same accountability standards applied to human users. The 2026 Enterprise AI Platform, beyond per token costs to total cost of ownership. The comparison table against Google Vertex AI and AWS Bedrock makes Microsoft's platform argument explicit. All three platforms share certain capabilities, but Microsoft Azure AI Foundry plus MAI checks 4 boxes that define enterprise TCO, and the other platforms do not. Ecosystem integration, direct integration with Microsoft 365, Copilot Studio, and Teams. Time to value measured in days, not quarters. Context unification through Microsoft IQ, a capability that merges work, Foundry, Fabric, and web contexts into a single unified reality, meaning the AI agent has access to your organizational knowledge graph, not just the text in a prompt. Compliance, an industry-leading certification stack purpose-built for regulated verticals, financial services, healthcare, government, and cost, native access to the 10 times more efficient MAI model family, a structural advantage that compounds with every token consumed at scale. AWS Bedrock lacks the compliance stack and the cost efficiency of native MAI. Google Vertex AI lacks both. The agent-first era is here. Stop renting intelligence. Start building it efficiently. This is the closing argument of the MAI presentation. The enterprise AI cost crisis was real. Frontier model dependency created a trajectory that was mathematically unsustainable at scale, as Uber discovered when it burned through a full year's AI coding budget in 4 months. MAI is Microsoft's structural answer. 7 self-developed models. A trillion-parameter sparse mixture of experts architecture that delivers frontier reasoning at mid-weight inference costs. 0 distillation. trained from scratch on clean, commercially licensed data. A competitive coding model that reduces token consumption by 60% through adaptive response length. Specialized models for transcription, voice, and image that surpass third-party alternatives on enterprise benchmarks. Frontier tuning that teaches models from operational data and achieves 10 times cost reduction. And the MXC security sandbox that makes autonomous agent execution governable, auditable, and safe. The message to enterprise technology leaders is direct. Access the MAI playground today via Microsoft Foundry. Evaluate MAI Thinking 1 and MAI Code 1 Flash in your own development environments. The agent-first era has begun. The question is whether you are building with the economics to sustain it.